Alright, in the last video I showed you exercise 9.1 number 16, and I was going to start doing B, and then I realized from a time perspective I couldn't really do that because I needed to Zoom with another class. And so I stopped myself short and thought I'd come back to B and we would do that together. So just as a reminder, we did all that work and came up with that there was sufficient evidence to support the claim. So now as we go to B, the most important wording is that we're going to construct the appropriate confidence interval. So if I look at that picture above, the appropriate confidence interval would still have a negative 2.33 involved. Well, confidence intervals are always two-tailed, so this must be 2.33. This was 0.01, this must be 0.01, and 98% lies in the middle. So you must identify the level of confidence. If you don't, you'll miss a point. Every answer in the back of the book is relating what level of confidence you did the test at. So we must identify that we're in 98% confidence interval. Well, we know how to do that. I take P1 hat minus P2 hat and add and subtract some error. We know that that error is a Z alpha over 2 P1 hat Q1 hat all over N1 plus P2 hat Q2 hat all over N2. And so we're good to go. Let's work on this error formula a little bit. The error formula, a Z alpha over 2, well, it's going to be the same 2.33 critical value. And then I need to get the P1 and P2 out of these guys. So P1, that's 15 out of 343. And if I subtract away 15 from 343, I get 328 out of 343. And that's still all over 343, right? P1 hat, Q1 hat all over N1 plus P2 hat, which was 27 cases of malaria out of 294. And if I take 27 off of 294, I get 267 out of 294. And that's all divided by 294. So now let's run this in our calculator and see what we get as our error. If we take the 2.33 and multiply that by the square root of 15 divided by 343 times 328 divided by 343 divided by 343, that one on the bottom, plus 27 divided by 294 times 267 divided by 294, and then divide that by another 294, will be set. And we end up with an error that looks like this, 0.046925, and then it just keeps going. I'll put all the numbers that I see. We know what to do with that error. If we're going to get a confidence interval for the difference, and we want that confidence interval for the difference because we want to ultimately show P1 minus P2 can't be 0. And so we want that confidence interval for the difference. So we're going to take our sample proportions, which was 15 over 343 and 27 over 294, and subtract them. That's going to be our base, our P1 hat, P2 hat. And then we're going to add and subtract the error. Well, let's take a look at 15 divided by 343 minus 27 divided by 294, and realize we get a negative 0.0481. I'll round it to 3 significant digits again. That's out 4 decimal places, so I'll take 4 decimal places of accuracy in my answer, in my error, I apologize. 0.0469. And what's left to do? Take the negative 0.0481 and subtract away the 0.0469 to get a low value of negative 0.095, less than P1 minus P2, which is less than, and if I add that error on there, look what happens. I stay negative 0.0012. We totally expected that to happen. I'm leaning over looking at what they have in the back of the book. For that part B, they identified as 98%, and we have the exact same numbers they have. And so this is great. And we have this exact interval that P1 minus P2 could be. So note that P1 minus P2 is not going to be 0, meaning we can reject the fact that they're the same. So we're saying we absolutely know P1 and P2 are different than one another. And because they're different, it's actually telling us which one is smaller. It's saying P1's smaller or P2's larger, however you want to look at it. Well, look at our claim that we were able to support, that the P1 was smaller than P2. That's exactly what we're seeing down here, that P1 is smaller than P2. Otherwise, this subtraction wouldn't be negative, and it's definitely going to be negative. How positive are we about that? Well, we're 98% confident about that. And so that's how these two different parts are actually saying the exact same thing. So that's what you're going to do in these two sections. Hopefully these two examples in 9.1, along with the written examples that are in the book, that are done in the PowerPoints, are sufficient. But if not, hop on to Zoom and I'm happy to help.